Last week we discussed how to set up some volumetric sims that are mainly just focused on density and velocity and temperature, but now we can take a look at some more combustion type effects. So this week we're going to take a look at how to do an explosion and fire. And for setting up the explosion, which we'll look at first and then take a look at the fire afterwards, it's actually fairly straightforward to set up the source for this explosion. The latest versions of Houdini come with some really nice tools that help us to create the source volumes that we'll need. So let's go into our file here, and I've created a geometry object to work on our explosion here. So inside this explosion object, let's first drop in our pyro solver, which might be jumping ahead a little bit, but if you take a look at the sourcing parameters for the pyro solver here, this can give you some hints as to what this is expecting for an explosion sim. So under the sourcing tab, you can see that by default, this is looking for a density volume and a burn source volume, which is going to be putting that data into a target field called flame. And it's expecting temperature and velocity. And as you saw with the dust and the shockwave sims, we don't necessarily always need to add all of these fields that the pyro solver is looking for. So for example, with the dust and shockwave, we didn't use a burn field at all. And for the shockwave, I didn't even bother with temperature. So don't consider this to be some sort of rule about what you have to be putting into the pyro solver here, but this does give us a good hint. So let's start by creating our source here. And there's this really nice tool that we can use called Pyro Burst Source. So if you drop that in here, this looks kind of complicated with lots of different settings to control your pyro sourcing. But really all this is going to do is it's just going to create a burst of points that we can then turn into a volume that will serve as a good starting point for our explosion. So the way that this pyro burst source works is that you put points into it and it'll create a burst happening at each one of those points. So just for the sake of example, let's drop in a sphere, and I'll turn that sphere into a polygon. Let's make this very low res because we don't need a ton of different points for this demo. And now if we pipe this sphere into the pyro burst source and display that source, you don't see anything right away because these bursts are animated on over a certain amount of time. And they have a start frame. You can see start frame is 1 right here. So if we go back to the first frame, then you can see we have all of these bursts that are happening at all of the different points on the sphere. So right now, all of these different bursts are overlapping with each other. So we can either shrink down the bursts or scale up the sphere to see this a bit more easily. So if I scale that sphere up by 10, you can see all these little bursts happening at all the different points on this very low res sphere here. And right now, all of these bursts are kind of doing the same thing. And we want some control to, vary up the behavior of all of these bursts per point. And if you look at the pyro burst source parameters here, you can see that a lot of them have this drop-down parameter that will specify whether you're setting a uniform value, you're setting some varying values based on this randomization control here. You have a seed and the amount of variation to apply. We have options to shift forward or shift backward. And then ultimately we have this option to use an attribute to control this value. Now, when we set this to use attribute, this isn't going to have the attribute automatically set up for us, so we'll have to set this somehow. So you can click on this little die image here to set up a randomization node to set some initial values on this. So if you click that, this creates an attribute adjust float before our pyro burst source, and this is going to give us a bit of an offset for all of these points so that they're happening at different times. So this makes for a much more interesting set of explosions here. This would already look pretty cool if we simulated this. And this is looking pretty interesting just on the sphere here, but this might look a bit more like a real potential scenario if we were to delete the sphere and instead let's drop in a grid. And after the grid, I'll just do a scatter and set the total count to 10 for just a handful of points, and then connect that to our Pyro burst source. So now if we scroll through our timeline here, you can see this series of bursts happening. So this could be like some sort of, I don't know, artillery barrage in a war scene or something. So that's looking pretty cool, but all of these explosions are still looking pretty similar to each other. So you may want to go ahead and do some further randomization on some of these other controls here. So on this Pyro burst source, I'll perhaps set some more randomization on this outward expansion here. So for that, I'll set that to use an attribute as well. And I'll once again click this die icon here to set a randomization on that. So if I bypass this attribute adjust float that was just added, it's not a massive difference, but it is varying up the amount of expansion between these a bit more. Right now our range length is pretty small here, so we could expand this a bit for some more variation. I'll set this to 5, so now we're getting some much bigger differences in the sizes of all these explosions. And we could also try randomizing some other things. For example, on this burst shape tab here, we could randomize the spread angle a bit. So I'll once again set that one to use an attribute, click the icon for the randomizer, increase the range length a bit, and maybe I'll change the grid size as well so that we can see the individual explosion bursts a bit more. I'll make this 30 units in size. So now, as I scroll through our timeline here, we should see quite a bit more randomization in the shapes and sizes of all of these explosions here. And you'll notice that these only exist for a handful of frames. Of course, the full explosion effects are going to last a lot longer, but we don't need to continuously source information into our explosion sim to keep it going. All we really need are these few intense frames of burn data and velocity and temperature. And perhaps it's a bit of a spoiler, but we're not going to need density for our initial input for this explosion sim because the Pyro solver can create some density when it's needed for the smoke later. So this is all looking pretty cool, and this would already make for a pretty interesting simulation, I'm sure, but let's apply this to the explosion for our creature. So if we take a look at this rendered and comped result, you might think that this explosion here really only needs one source. And sure, perhaps you could get a pretty cool explosion simulation by just using one source for this, but it can make things much more interesting if you have a couple different sources that happen offset from each other. So for this result, I have one initial explosion source here, and then after about 5 frames, there's a second one that happens inside there, just slightly offset, slightly different shape, and that's also feeding in sort of a secondary explosion event into this sim, which just makes for a more interesting and dynamic result than we would get out of just the very single explosion burst source. So now to apply this to our creature here, I'm going to, of course, import that for reference. So I'll drop in an object merge, and I'll point this to object/creature ground, and I'll point this to the out creature jolt null. So if we display that, you can see that this creature that we're bringing in is animated. It's a pretty simple little jolt animation on this creature here, just to help sell the impact of that explosion. And this isn't a terribly heavy animation, but I would like to time freeze this so that we're not loading up all of these deformation frames while working on the explosion sim, because the explosion work is heavy enough on its own without us loading in unnecessary animation stuff that we don't necessarily need to see right now. And in this case, I set up the jolt animation so that it lands and rests in its starting position. And you don't need to set up your jolt animation so that it lands back in the same position that it started. I just set it up that way so that we could simplify things for our pyro effects and so that we wouldn't have to worry about whether or not our effects are lining up with some changing animation. Whenever you're doing effects work, the fewer dependencies you have between different effects, the easier things will be, because when you have multiple things dependent on each other, as soon as one thing changes, that means you have to change all the other things that are related to that. So it can certainly help your workflow to keep things as independent as possible. Of course, it doesn't always work out that way in production, but it certainly can simplify things. So now let's drop in a time shift. Control-Shift-click the frame to get rid of that expression. I'll set that to frame 1. And let's template display that. And now let's add a couple points for those burst events that are going to happen inside the mouth of this creature here. So we can delete this initial pyro burst setup here. I'm going to leave the pyro burst node itself and just delete the randomization and the scattered points that were going into that. And we can set our own points in here. So if you just want to place where this is happening manually, you could just drop in an add SOP and turn on this point addition here. And let's display that. Hit enter in the viewport to move that around. And I'm going to turn on point snapping here to help move that into position by the creature. So if I click and drag that over to the mouth of the creature here, that's going to move this point that we created onto the surface of that creature mesh. And then I'll disable that point snapping to fine-tune this position a little bit more. So we can put this explosion right in the middle of the creature mouth there. And maybe I'll push that inwards a little bit more so that the explosion is starting just a little bit deeper in that mouth area there. Like so. That'll work well. And now I'm just going to copy this add SOP. And then I'll move this second explosion source to happen a little bit further out and maybe a bit more toward the top. And this is one of those things that you can play around with and, move around your different explosion sources, play around with how many explosion sources you want to feed into this effect, where they're located, how large they are, and etc. So I'm going to try this. Let's merge these 2 points together and then add these points into our pyro burst source. And right now, these points are going to be exploding back at frame 1. And because we've gotten rid of our attribute randomization, they're both exploding at the same exact time. And when I'm only using a couple of points like this, I generally prefer to, rather than randomize this, I will just set some explicit values for these attributes. So I'll drop in an attribute wrangle, drop that underneath the first add. And back on this pyro burst source here, I actually am going to turn this randomizer back on just for a moment to check the exact attribute names that this is expecting. So I'll hit this die icon again. You can see that the spread angle is expecting this exact attribute name here. So I'll copy that, paste that into our wrangle here. And because at the moment I'm putting in some malformed vex here, I'm just going to set my scene to manual so that this doesn't freak out with incorrect input just as I'm grabbing these attribute values. So let's delete this attribute adjust float for the spread angle. And back on the burst animation, let's create the randomizer for start frame. And we'll create it for outward expansion as well. So start frame is just called start frame with no underscore in this case. So I'll paste that into the wrangle as well. And for expansion outscale, I'll grab this name, put that in our wrangle, and then delete these attribute adjusts as well. So looking up those names in that way can be fairly helpful because you see it's not always consistent in terms of how they're named. So now that we've gotten these attribute names for those parameters that we want to vary up between these two explosion points, let's set those values. And these are just going to be standard decimal float values. These aren't vectors or anything. So I'll type in f at in front of all three of these, and then set the values manually. So this first explosion point, I'm going to have exploding at frame 80, which is what we had previously determined, and that's the timing that we animated the creature jolt to as well. For the spread angle, I'm going to go with something a bit more narrow so that we can get this outward burst kind of shooting out of the mouth here. So I'll set a spread angle of 25, and for the outscale, I'll just try a value of 3. I'll rename this wrangle to burst attributes, and let's copy that, place that under the add to as well, and I'm going to leave the spread angle and the outscale the same for the moment, and for now I'm just going to offset the timing and set the start frame on that one to 85. So now let's take this off of manual, set that back to auto update, and display our burst source, and then jump ahead to frame 80. So right now we have this little burst happening in there, and a second burst happening at frame 85. And right now these bursts are just shooting upwards, but we want these to shoot out of the mouth, so we need to change the direction on this pyro burst source here. So if we take a look at the axis that this creature is pointing down, it looks like this mouth of the creature is pointing mostly in the positive z direction, a little bit in the minus x. So on our pyro burst source here, I'll set the direction to 0 in y, 1 in z, and I'll try maybe just minus 0.6 for the x direction. Might be a little bit too much x. Looks like minus 0.4 might be a little bit better, but of course we can tweak this later. And I want these explosion sources to be larger as well. I want this to be a pretty big and dramatic explosion, so I'll set this initial size to be 4 times bigger. So if we go back to frame 80, where our first burst starts, we can check the progression of that over the first few frames, and this is looking pretty good. Of course, we can also change up the shape a bit as well. If you like the overall size and behavior of this initial source, but you're not quite happy about exactly where these different spikes are happening, we can just vary that up on this pyro burst source here by changing the shape offset until you find something that looks a little bit nicer. So when I change that shape offset to 10, I think this shape is looking quite cool. So you can play around with this until you get something you're happy with. I like how this shape is looking here, although it looks like this may need a bit of reorientation. So I'll just tweak that direction a little bit so it's coming out of the mouth a little bit more straight. This is looking pretty good like that. So now let's check the second burst. And because this second burst is going to be emitting into an explosion sim that's already started, I'm going to be a little bit less picky about getting the shape of this one just right. But I do want to tweak this a bit. This also doesn't need to be quite as big as the first one. So under the burst attributes for this second source here, I'm going to turn down this outscale a bit. I'll set that to 2, make that a bit smaller. And this one can also be a little bit more omnidirectional. I don't necessarily want this to be a completely spherical burst source here, but it certainly doesn't have to be quite as directional as the first one. So I'll tweak the spread angle on this. So setting that to 90 gives us a pretty nice and wide source here. And because this explosion is really going to be just filling up this entire area, especially for those initial frames, we don't have to worry too much about these explosion sources passing through the geometry like this. That's not really going to cause a problem for us. So these explosion sources should work quite well, although we could even increase the spread angle a bit more on the second source so that this explosion kind of wraps around the creature a bit. So I'll try increasing that second spread angle up a bit higher to 130. That should work pretty well, although maybe I'll also pull that just a little bit further out of the mouth area there. This looks all good, although I probably don't need to obsess about it quite that much. So let's take a look at creating the actual volumes from these points here. Now this pyro burst source has, under the burst components here, some tabs that will create the necessary attributes for our pyrosim. So you can see this defaults to creating the temperature and the burn for us. And I'm just going to leave these values at their default of 1. That should be just fine. And in addition to these attributes here, this is creating a bunch of other attributes as well. You can see we have a velocity on all of these points that you can visualize if you display the point trails here. That's going to give us some nice outward force. And we have some additional information such as burst ID and source name. And we have a p-scale that's going to help with the volume creation from these points as well. So now that we have these points with all of these helpful attributes, we can drop in a volume rasterize attributes. And on the attributes drop down here, we can select burn, temperature, and velocity. And I'm going to leave the voxel size and particle scale and everything as they are. I think this resolution works just fine as a decent starting point for this. At this particular scale, it's not terribly heavy to use that voxel size of 0.1. Of course, we could potentially push this higher resolution later as we continue with the sim and we approach our final simulation, but this should be all good for now. And if you do push the resolution of this volume source much lower or higher, you might find that you need to tweak the point density as well. So on this pyro burst source here, if you go to the burst shape tab underneath the trail separation here, you can make this a more dense point cloud by reducing this trail separation. So if I set that to 0.05, then this is much more dense. We have far more points in this output, and you can also change the number of trailings here, which are going to essentially be the number of spikes that we see representing this shape. So if we drop this down a lot lower, you can see we only have a handful of spikes. So you can dial that in to taste. I think the default number of trailings and default trail separation are working pretty well for us though. We also don't really need to mess around with the trail length or thickness in this case. If you reduce the trailing length, that's going to push the points out just kind of to the outer shell of this burst shape that we're creating, which could be interesting for some effects potentially. But I'll just leave that set to 1, and this trailing thickness will essentially be the thickness of each one of these spikes here. So increasing that will make those all quite a bit fatter and really fill up that space. Once again, I'm just preferring this default shape here, so I'll leave that all alone. And now if we display the volume rasterize attributes output and middle mouse on that, you can see we now have a burn and temperature and velocity. So now we're all set to plug this into our pyro solver and start setting up the actual simulation.